Hello, this is Mr. McFarlane with your Geometry Screencast, Chapter 6, Section 3, Tests for Parallelograms. Alright, here we go. Theorems. 6.9. So, we've learned that if it is a parallelogram, that the sides, opposite sides, are congruent. Well, the reverse is also true. If opposite sides of a quadrilateral are congruent, then it is a parallelogram. There you go, that's 6.9. 6.10, same thing for the angles. If opposite angles are congruent in a quadrilateral, then the quadrilateral is a parallelogram. And 6.11 tells us if the diagonals bisect each other, then the quadrilateral is a parallelogram. There we go, 6.9, 6.10, and 6.11. Finally, 6.12, if two sides are parallel and congruent, then the quadrilateral is a parallelogram. All right, determine whether the quadrilateral is a parallelogram. All right, what do we know? We know this side is congruent to this side. They're both 14, and we know that angles G and H, being consecutive interior angles, are also supplementary. Therefore, we know that these two lines are parallel. Since they are parallel and congruent, FGHJ is a parallelogram. All right. In this diagram, we see a side view of a tackle box. In the diagram, PQ and RS, PQ is equal to RS, and PR is equal to QS. All right, so right here we're looking at this quadrilateral. Explain why the upper and middle trays remain parallel no matter what the height of the trays. So, whether they're raised or lowered, since both pairs of opposite sides are congruent, this is congruent to this is congruent to this, we have a parallelogram. Since opposite sides of the parallelogram are parallel, PQ must be parallel to RS, no matter how you tilt it. So it's always going to be parallel. All right, and here we go. We have in this parallelogram, FK is 3x minus 1, KG, this segment is 4y plus 3, JK is 6y minus 2, and KH is 2x plus 3. Now we need to determine x and y. We don't know that it's a parallelogram. We need to determine them so the quadrilateral is a parallelogram. Now let's label them in here so you have a visual. Okay, so we know this segment and this segment. In order for this to be a parallelogram, the diagonals have to bisect each other. That means we will set these equal because the segments have to be equal. So 3x minus 1 is set equal to 2x plus 3. And solve that for x, we get x equals 4. Same thing here, set these two segments equal 6y minus 2 is equal to 4y plus 3. Solve that and we get y equals 2.5. All right, so here we go. In order to prove that a quadrilateral is a parallelogram, you can either 1. Show that both pairs of opposite sides are parallel, or 2. Show that both pairs of opposite sides are congruent. 3. Show that both pairs of opposite angles are congruent. 4. Show that the diagonals bisect each other. Or 5. Show that a pair of opposite sides is both parallel and congruent. Okay, we want to graph this quadrilateral here with these vertices and determine whether it is a parallelogram. Now we're supposed to justify using the slope formula. All right, graphing that on the grid, we've got this quadrilateral. Using the slope formula from K to L, I'll find the slope from K to L. If opposite sides are parallel, we know it's a parallelogram. So the slope of k to L is up 1 over 6, or you can find it from here, up 1 over 6. And then the slope of this line, MN, or NM, is also up 1 over 6, or we can find it between the two lines, up 1 over 6. So these two have the same slope. And finally, LM is a slope of 6, up 6 over 1, and NK is up 6 over 1. So we know that these two have the same slope, and these two have the same slope. Since the opposite sides have identical slopes, that means KL is parallel to NM, and LM is parallel to KN. So it is a parallelogram, and that is it for today. Remember to like and subscribe. Thumbs up like it's your business. If you don't want to add this to your liked videos, you just write in the comment that you like this. This was your favorite video ever.